Okay, so here's a couple of examples of basic mole-to-mole stoichiometry problems. So this is just the first set. So if you want to take a second, read the question. It says ammonia is made by reacting nitrogen and hydrogen, and then it gives you a certain amount of moles of hydrogen to react, and then it wants you to know how many moles of ammonia will be produced. So the first thing you want to do always is to go ahead and write out the reaction if one is not given for you, and then the second thing you want to do is make sure that reaction is balanced. Otherwise, you can't really do these problems correctly because you need the mole to mole ratios in order to complete these tasks. Okay. Um, so right away in the statement, I noticed this nitrogen and hydrogen. So hopefully this trigger diatomic elements in your brain. And then hydrogen here is in the red in the upper left corner, and then that is one of the diatomics. And then nitrogen is number 7 there, and that is also a diatomic. And this is important to keep in mind because you do need to include subscripts in your reaction. So here I have N2 plus H2 produces ammonia, and that's what the statement originally gives you. And then, in order for you to calculate the number of moles of ammonia that will be produced, again, you first have to make sure your reaction is balanced. Um, so here I notice that there are 2 nitrogen atoms and there are 2 hydrogen atoms, but ammonia only has 1 nitrogen and it has 3 hydrogens. So this one's pretty easy. So if you want, I would just recommend that you recognize that on the reactant side here, there are 2 nitrogen atoms. So to make the product side has a 2n as well, you would just multiply by a coefficient of 2. But then keep in mind that coefficient in the front gets distributed to nitrogen, and it also gets distributed to hydrogen. But this is an H3, so really it makes an H6. So because 2 times 3 here will give you 6 hydrogen. That's important because on this left side where the reactant is, this hydrogen has only 2. So to make that a 6 as well, you need a coefficient of 3 in the front. So again, distribution of 3 to 2, that'll give you a 6. And then over here, 2 to 3, that also gives you 6. So this one's pretty straightforward, no trick here. So from here, we can determine the mole to mole ratio. Here's the 1. Again, the N2 has no number in front of it, so you need to visualize a coefficient of 1. There's 3 moles of hydrogen, and then there's 3 moles of ammonia. So from here, we can set up the question. It wants to know how many moles of ammonia. So you always want to first start though with your given value. So in this case, the statement gives you 4 moles of hydrogen. So you want to go ahead and start with that. I like to put the given values over a 1, just so you have a nice fraction throughout the whole entire problem. So visually, I think it helps canceling stuff out without making errors. Okay, so that 4 moles of H2 comes from the statement up here, and that's where that comes from. So we just carry it down. Again, start with the given statement, and then from there, these question mark that I have here, which is the next step, it'll guide you. So the way I think about it is that there's moles of H2 here, and you want to go from moles of H2 to ammonia. So you have to recognize in this statement what I did on the screen here. I just took N2 away because it has nothing to do with this particular question. So if you want, you can mentally erase that. So it keeps you focused on the coefficient of 3 and the coefficient of 2 here and these two compounds. Okay. So the next step would be to go ahead and write stuff out so things cancel. I just carry this particular step down to here. Here you notice in the numerator you have moles of H2. So you want to cancel out moles of H2 by placing it in the denominator in the next step. Um, and then you want moles of NH3, and what you want, you should place that in the numerator in stoichiometry. And then from here, you can just use the balance reaction by doing mole to mole ratio. So this is your mole to mole ratio. These types of problems are pretty straightforward. And then from the balance reaction, you can just pull out numbers that you need or information that you need. Here, the coefficient in front of H2, excuse me, is just a 3. I carry that down there. And then the coefficient in front of ammonia is a 2, so I'll carry that 2 there. So it's important that you place the coefficients where they need to go. Otherwise, your final outcome is going to be a little screwed up. Okay. So next, we would just, out of formality or good habits, cancel units out. So moles of H2 in the numerator here will cancel out with moles of H2 and the denominator in the next step. And so the only thing you have left is moles of ammonia, which is what the question is looking for. So from here, it's pretty much calculator work. So 4 times 2 is 8, 1 times 3 in the denominator is 3. And then if you do 8 over 3, you get 2.66666 running. But in this case, the answer is rounded to 2.7 because in the original statement, where the cursor is, it says 4.0 moles of H2. That right away is 2 sig figs because the 0 is significant. So you want to round your answer off to 2 sig figs so that everything matches. Okay, so your final outcome needs to have 2 sig figs. In this case, it will be 2.7. So make sure you round correctly in your calculator. And there's the first example. The second example that I have here for you, um, this one, it says how many moles of sodium will react with water to produce 4.0 mole of hydrogen in the reaction shown below. So for this one, the reaction is already given. Everything is already balanced for you. If you notice here, all the coefficients are done for you. So you don't have to do this particular balancing step. So this right away is a mole to mole ratio because it asks for how many moles of sodium, and it also asks for it also gives you moles of hydrogen. So pretty straightforward for stoichiometry with this one as well. Okay. So what I like to do is I like to get rid of compounds or reactants products that doesn't really involve in the problem. So it's here on the screen. I'll go ahead and backtrack there. It wants sodium and hydrogen. So I don't really need to involve water and I don't really need to involve sodium hydroxide. So I'll go ahead and take that off of the reaction there, just so you can kind of focus on just two things, sodium and H2. Okay. Uh, so similar to the last process, start with what you're given. You're given 4 moles of hydrogen, and that is 4.0 moles of H2 there. And then from there, you can just go to the next step. But you have to figure out again what the questions marks are in terms of stoichiometry. Really, you're just converting from 1 mole of one to the next mole. So from here, just carry this down, and that's where that comes from. And the next line will give you the next or the next conversion factor, essentially, or mole ratio, if you want to call it that. So start with 4.0 moles of H2, put it over. I like to call this a sexy one. It's just a placeholder. So you have numerators and you have denominators. And then here you have moles of H2 on top. So moles of H2 needs to go on the bottom or denominator in the next step. And then you want moles of Na. So what you're trying to find, again, should go in the numerator if you kept it with the last example. From here, we can just place numbers where they need to go. On the screen that just came up, H2 has no coefficient in front of it. So the coefficient is just a 1. So that's where that 1 in this denominator just came from. So I'll carry that down. And then here in the balance reaction, in front of sodium Na, you have a 2, and that's where that 2 comes from. So using the coefficient in front of a balanced reaction gives you the mole to mole ratio. And then from here, just basic math. We cancel out moles of H2 again. We cancel out moles of H2 again. And then 4 times 2 is 8. And then 1 times 1 is 1. 8 divided by 1 gives you 8. But in this case, the answer is 8.0 moles of Na because in the original question, it gives you 4.0 mole of hydrogen, which is 2 sig fig. 4.0 is 2 sig fig. So pay attention to sig figs. Make sure your final outcome is rounded properly, and then it has the right sig fig. In this case, it'll be 8.0 moles of Na, not just 8. Okay. Other than that, that's the pretty straightforward mole to mole ratio problems. All right.